Hey guys, my name is James F. Williams and this is everything that you need to know about dilutions. Dilutions, simply put, are changing the strength of a solution. But then what is a solution? Solutions are compounds or solutes that have been dissolved or dissociated in a solvent, such as table salt, into water. This is now a solution. Dilutions can be made stronger or weaker by either adding more of the solute or more of the solvent. More of the solute makes it stronger, more of the solvent makes it weaker. There's a really strong relationship between concentration, or how strong a solution is, and dilution, all of which I'll be covering in a later video. So don't forget to subscribe to the YouTube channel or check stream.bangor.ac.uk to find out when that video goes live. Dilutions in science have many different purposes. However, they're generally used to compare the effect of concentration on another factor or another variable. For example, honey concentration on hydrogen peroxide production in bees. The units for the strength of a solution, or the concentration, are generally the mass of the solute over the volume of the liquid you've used. For example, grams over liters, or molar, or moles over liters, for example. But it's all well and good of me telling you all of this practical mumble jumble, but how exactly do you go about making dilutions? This is how. The first major step of any dilution is adding more of the solvent in order to make the solution weaker. The solvent is generally distilled water, but you can use whatever your original solvent was. It's generally a good practice to take some of your original solution out in order to make that weaker, because it's a lot easier to make things weaker than it is to make them stronger. After adding the necessary water that you need to make your new solution, you need to stir the solution so that you have a constant concentration throughout. But how much water do you need to add to get the concentration that you want? All you need is this equation where C1 equals your first concentration, C2 is your final concentration, V1 is your initial volume, and V2 is your final volume. Then all that you need to do is fill in the blanks and solve the equation. So let me help you apply this formula to a solution that I did earlier. So the way that you start any dilution is that you write down the formula that you need. So C1 being your initial concentration, C2 being your final concentration, V1 being the volume that you start with, V2 being the volume that you will end with. Normally you have your initial concentration, you have your initial volume, and you know what concentration you'll want in the end. So hopefully you can see that there. Let's try and apply it to a simple equation. So I want 0.1 moles per liter of sodium chloride from 0.5 mole per liter sodium chloride, and I already have 200 milliliters of it. So what I'm doing here is effectively a fifth dilution. It's always a good idea to estimate about how much you're going to need so that you know you're in the right ballpark. So first off, I'm going to write V2 here, so that I can know what my equation is. Because all you're doing now is you're balancing an equation of 0.5 moles per liter times 200 milliliters equals 0.1 moles per liter times V2. So 0.5 times 200 milliliters, we're going to remove the units for the time being because they all have the same units effectively. That way it's easier to know what you're working with. 0.5 times 200 equals 100. That's not too difficult. Timesing by 0.5 is the same as dividing by 2, and that still equals 0.1 times V2. Then you're going to take over the 0.1 over to the side, which is 100 divided by 0.1 equals V2. 100 divided by 0.1 is the same as timesing by 10. So you're timesing that by 10, and that takes you to 1,000 milliliters equals V2. Now what you have to remember is that you already have the initial volume of 200 milliliters, so you need to resubtract the 200 milliliters that you had in the first place from the 1,000, so you know that the amount of liquid that you need to add is now 800 milliliters. And hopefully that makes sense. If you have any questions about this, feel free to drop them in the comments below. So thanks for watching. Hopefully this video has been useful to you and now you understand what dilutions are and how you conduct dilutions. If If you have any questions or any dilution related queries, feel free to drop them in the comments below and I'll answer them when I can as soon as possible. I'll be making lots more videos like this covering basic lab concepts, so don't forget to subscribe to my YouTube channel and checking out on stream.bangor.ac.uk to find out more about when I'll be releasing videos like this covering stuff like concentration, how to use a microscope properly, how to scientifically draw accurately, and lots of other things that you need to do if you're starting university in September or if you're just interested in science at all. Thanks for watching. My name's been James F. Williams and I'll see you in the next one.